Alright guys, today we're going to be talking about how you can determine whether functions are inverse of each other. So this is a pretty simple process to go through. You're just going to use compositions to do this. So for example, you're going to set up two compositions here. The first one's going to be f compose g of x, okay? And then you're going to have g compose f of x. When you do both of these compositions, if they both equal the input value, in this case it's going to be x. So if these both equal x here, when I do this, okay, the input value, that's going to tell me that they're both inverse of each other, okay? So let's go ahead and do this, and we're going to determine if these functions, okay, are inverses. All right, so let's go ahead and do this out. So we have f compose g of x. Remember, when you're dealing with compositions, you work your way from the inside out. Okay, so we're going to start with g of x, and we're going to go ahead and just plug it right in here. So we'll have f, and then in parentheses we have 3 over 2x minus 9. So at this point, you're just going to go to your function f of x, and wherever you see an x, you're going to plug this part in. Okay, so we're just going to go ahead and write this. We'll have 2 over 3, and then here's my x. I'm going to write this whole part in. I have 3 over 2 x, and then minus 9. Okay, and then you're just going to write plus 6. Plus 6. Okay, let's do this out. So we know that this part right here we're going to distribute, okay? So when we distribute to our first term here, we have 2 over 3 times 3 over 2, right? Well, again, this is just going to cancel both on the numerator and denominator, and we're going to be left with just x. So right now we have x. We also have to distribute here, so negative 9 times 2 is negative 18. And then negative 18 divided by 3 is negative 6. And then write plus 6. Okay, negative 6 and plus 6 cancel each other out, and we're left with just x. Okay, so this guy checked out, all right? Okay, so now we're going to go ahead and do this composition here. And if we do it and it equals the input value, in this case x, we know that the functions are inverses. All right, so let's go ahead and do this out. So again, working our way from the inside out, we're going to go ahead and write f of x, which is the following. So we have g, and then 2 over 3x plus 6. Okay, then we go to our function g of x, and wherever we see an x, we plug this part in. So we're going to write 3 over 2. Now here's my x. I'm going to go ahead and write this whole part in. 2 over 3 x plus 6 and minus 9. Okay, again, we're going to go ahead and distribute this here to both terms. This here, we know that they're going to just cancel on both the numerator and denominator. We'll be left with just x. Okay, 3 times 6 is going to be 18. 18 divided by 2 is 9, so plus 9. Then we have a minus 9, a plus 9, and a minus 9 cancel. We're left with just x. So what that tells us is, yes, the functions are inverses. Okay, it checked out. So that is how you can determine whether functions are inverses using compositions. Okay, here's another example. So we're going to go ahead and check to see if these functions are inverses. Okay, so we're going to go ahead and set up our composition. So again, we're going to have f compose g of x, and we'll also have g compose f of x. Okay, so let's go ahead and check this and see what happens. So again, I'm going to start from the inside out. So we have g of x right here. We're going to go ahead and plug that in. So we have f, and then we have g of x, which is 1/2 x minus 4. Okay, we're now going to go to our function f of x, and wherever we see an x, we're going to plug this whole part in. Okay, so we're just going to rewrite it as 2. And now here's my x. I'm writing this whole part in. 1/2 x minus 4, and then plus 4. Okay, we have to distribute this guy to both of these terms. So we know that this is just going to become x, right? 2 times 1/2 is going to just be 1, so 1x, or just x. Okay, and then 2 times a negative 4 is going to be negative 8. And we have plus 4, and we're left with x minus 4, okay? So notice here that when we did this composition, it did not equal the input value, which in this case is going to be x. Okay, we got x minus 4. Okay, so what this tells us, we actually don't have to go any further. Since this did not equal the input value, which in this case is x, okay, we don't have to go any further. We already know that these are not going to be inverses, so this did not check out. Okay, so we don't even have to go ahead and do this composition. It didn't equal the input value. All right, this problem is now complete.